Hello, students. How are you, dear? So, guys, once again, a very warm welcome to you all to your very own channel. Let's crack Neet UG in English. Myself, Sharada Alok. I've been teaching chemistry at Resonance from past 10 years. Now, let me tell you how you can get connected to us first of all. Guys, first of all, go to Play Store, download the Unacademy learning app, and then click on to Neet UG, and you'll be finding two type of subscription. One is plus subscription, another one is iconic one. Let me tell you about plus subscription, guys. Come on, but before that, I just want to tell you all to share the link of this session to all your friends who are preparing for NEET 2021, 2022 KVPY and board examination. Because today's session is discussion of previous year's questions of periodic table from which have been asked in NEET so far. So do share the link to all your friends who are preparing for NEET 2021 KVPY board examination and also NEET 2022, guys. Come on, let me tell you all about plus subscription. So guys, here you'll be getting daily live classes by the top educators across the nation. Not only that, you can engage in discussion, ask all your doubt and answer in the poll all while the class is going on. And these polls are going to have questions related to the topic being taught on the screen. You'll also get live tests and quizzes which will help you to evaluate your preparation with regular mock tests and quizzes, and you'll be getting a detailed analysis of your performance. So all by having this plus subscription, you'll also get guys structured course, and all our courses are structured very much in line with exam syllabus, which will help you to make you prepare yourself best for the exam. Come on, all by having one subscription, guys, one plus subscription, you get access to all our live and recorded courses, which you can watch from the comfort of any of your devices. Now, guys, let me tell you about iconic subscription. This will definitely take your NEET UG preparation to the next level with personal coach. Come on, the top educators across the nation will you be your personal coach. You're going to get one-on-one guidance from top exam expert as a personal coach in order to align your preparation strategy. You will also get an in-depth test analysis with personalized feedback in order to improve your time management and of course exam approach. So guys, you'll be getting a proper study planner that will ace your preparation with customized study plan. You will be getting a bi-weekly review that will definitely highlight your progress. So all by having one iconic subscription, you'll be getting live classes from top educators, mock test and quizzes, structured batch courses very much in line with the exam syllabus. So guys, must be wondering whether to go for plus subscription or the iconic one. I just want to tell you whatever you are going to get under plus subscription, you'll be getting all that under iconic one along with the iconic features like personal coach, study planner, expert guidelines, and of course, in-depth test analysis. So you need to select a plan that suits you. So guys, for iconic subscription, you can go ahead for 6 months, 12 months and 24 months subscription. For 6 months, you'll have to pay 38,000. For 12 months, you will have to pay 65,000, and for 2 years, you'll have to pay 1 lakh. But if you apply this referral code of mine, you'll get to know that you'll have to pay only 34,200 for 6 months, 58,500 for 12 months, and 90,000 for 2 years, which is going to cost you only 3,750 rupees. I would like to personally recommend you that if you are a student of class 12 or have taken drop, you must go for the 6 month subscription by paying 34,200, which is simply going to cost you 5,700 rupees per month, and this is also available at no cost EMI. Now guys, let me tell you all about plus subscription. Right from 1 month, 3 months, 6 months, 12 months and 24 months subscription you can go ahead for. For 1 month you'll have to pay 7,000. For 3 months you'll have to pay 17,500. For 6 months you will have to pay 28,000. For 12 months you'll have to pay 38,500, and for 2 years you'll have to pay 56,000. But if you apply this referral code of mine, you'll find that you'll have to pay only 6,300 for 1 month, 15,750 for 3 months, 25,200 for 6 months, 34,650 for 12 months, and 50,400 for 24 months, which is going to cost you only 2,100 rupees per month. And remember, this 6 month, 12 months, and 24 month subscription are also available at no cost EMI as well. Now, guys, there's something else which I just want to share with you all, guys. We are going to start this Umeed batch in order to turn your Umeed into reality for excelling into Neet 2021. So, guys, just do this batch, which is going to start from 3rd of January. This is a crash course for Neet 2021. And if you really want to prepare for medical entrance examination with top educators, do join this batch, which is going to commence from 3rd of January and will be mentored by the top educators across the nation, available at Unacademy, guys. Yes, you will be mentored by Dr. Anand Mani sir, Aman Kumar Singh sir, Deepak Vashist sir, Vikrant Kirar sir, and the batch is going to start from 3rd of January. Guys, come on, have a look at the mentor once again. Those who are going to turn your Umeed into reality for Neet 2021, guys. So do join this Umeed batch where you'll be mentored by Dr. Anand Mani sir, Deepak Vashist sir, Vikrant Kirar sir, and Aman Kumar Singh sir. Now, guys, one more batch is started from 28th of December. That is Super Ranker batch for Neet 2021. Come on, it has started from 28th of December. This is a crash course for Neet 2021. If you really want to prepare for medical entrance examination with top educators and do want to achieve the super rank in Neet 2021, do join this batch. Come on, you'll be mentored by Ashish Diwan sir, Pankaj Talwar sir, Ritu Rattewal, Ma'am Pradeep Chittora sir, and Rohit Kumar sir. This batch will start from 28th of December till your Neet 2021, so that to ensure you get super rank in Neet 2021, guys. Come on, you'll be mentored by Ritu Rattewal, ma'am, Pankaj Talwar sir, Ashish Diwan sir, Pradeep Chittora sir, Rohit Kumar sir. So if you really want to get super rank in Neet 2021, do join this batch. Now, one more batch is Abhyas batch, guys. Right from 23rd of December to your Neet 2021, this batch is going to make you vigorous practice, vigorous Abhyas for Neet 2021. If you really want to prepare for medical entrance examination with top educators, do join this Abhyas batch and have a vigorous practice. You'll be mentored by Anmol Sharma sir, Gaurav Verma sir, Pankaj Talwar sir, Shashi Prakash sir. Come on, do join this batch and have a vigorous practice for Neet 2021 in order to ensure your wonderful rank. Come on, you'll be mentored by Anmol Sharma sir, Pankaj Talwar sir, Gaurav Verma sir, Shashi Prakash Singh sir. Yes, guys, right from 23rd of December to your Neet 2021, you'll be mentored by them. So let us start with the very first question of periodic table, guys, which has been asked in NEET 2017. Guys, on your demand, I have started this new session on discussion of previous year's question, which all have been asked so far in NEET, guys, or AIPMT as well, so that you'll get a clear-cut idea about the questions which are going to be asked from particular topic you're preparing for NEET 2021. So today's session is to discuss the previous year questions of periodic table. And in continuation to that, the very first question is the element Z with atomic number 114 has been discovered recently. It will belong to which of the following family or group and electronic configuration? Come on, guys, I just want to give you a wonderful trick over here. Guys, if you are asked to find the group number of any element right from 100 to more, how to find out the group, guys? See, group number 3 for element 100, 101, 102 and 103. Why? Because these are all actinides, and actinides so child lanthanoids, they all are present in group number 3. Now, guys, how to group numberize right from 4th, that is 104 to 118? Simply, guys, group number will be equal to atomic number minus 100. Okay, So if you talk about the group number of an element which is having atomic number 104, will have a group number 4. That is 104 minus 100 is 4. What about 118? Guys, 118 minus 18. Yes, 118 minus 10 is 18. So it belongs to 18 group and this belongs to 4th group. What about 114 then? 114 minus 100 will give you 14th group. Okay, guys, and we know that right from 13th to 18th group, we have P block element. We have P block element. And guys, 13th one is boron family. 14th one is nitrogen family. 15th is, yes, 14th is carbon family. Sorry guys. This is carbon family. This 15th is nitrogen family. 16th is oxygen. 17th is halogen, guys, and 18 are noble gases. Okay, so this 114 belongs to carbon family. It belongs to carbon family. Remember the trick, guys. How to identify the group number of elements with atomic number right from 100 to more is simply, guys, subtract 100. Simply subtract 100 to yes, group number. Yes, guys, will be obtained by subtracting 100 to 104. And remember, for all elements like till 103, guys, till 100 to 103, they actually all are present in group number 3. You need not to worry for them. Okay. Right from 104 to 118 will be guys obtained. The group number will be obtained by subtracting 100 to the atomic number. Just remember this trick. Okay, come on. Is that clear? And remember, guys, all these period number, if you are asked to tell, all these elements with atomic number 102, 118 are all present in period number 7. Remember. So it is very easy to find out the position of such elements with atomic number 100 to 118, isn't it? Come on, let us go to the next question. Now the next question we have, this was asked in Neet 2016 phase 1. So we have the question, guys, in which of the following option, the order of arrangement does not agree with the variation of property indicated against it. Okay, so let us see the first one. First is, guys, boron is having less than carbon, further less than nitrogen, then oxygen, increasing first ionization enthalpy. Now remember, guys, no doubt as we move across the period, Z effective increases, therefore ionization energy also increases. Just write it down, ionization energy also increases. Done. So guys, when we move across a period, first of all we find boron, then carbon, then nitrogen, then oxygen. But in case of nitrogen, guys, we have to remove the electron from 2p3, whereas in case of oxygen 2p4, here 2p2 and here 2p1. So guys, this nitrogen is having extra stability due to half filled subshell, isn't it? The maximum electron which p subshell can occupy is 6, guys. Here each orbital is half filled and half filled is stable. Guys, half filled stability is more than partially one. Half filled stability is more than partially filled orbital. Is that clear? Therefore, it is very, very clear from here that the correct order of first ionization enthalpy will be this one. Done. So this is wrong. So this does not agree with the variation of property indicated against it. So this A can be the option here because this does not agree with the variation of property indicated in the bracket. And we have to click only to that. So guys, this is okay now. Now the next one is increasing electron gain enthalpy. So guys, this is also does not agree because the actual order of electron gain enthalpy is this much, is actually this order. because because here the electron has to enter into 2p orbital, which is and in case of chlorine the electron has to enter into 3p orbital. And if you compare the size guys, 3p is bigger than 2p, so this 2p has, this is the order of size. And if you talk about extent of repulsion, due to smaller size, the extent of repulsion is much more in 2p than 3p. So some energy is required to overcome the repulsion. Remember, energy is required to overcome the repulsion to the incoming electron. And some energy is used up in overcoming the repulsion, and therefore less energy is released. Therefore, this is the correct order of first electron gain enthalpy. So guys, chlorine will have maximum electron gain enthalpy, than fluorine, than bromine, than iodine. So this also does not agree with the variation in property mentioned there. Done. Now let us see the third one, guys. Lithium, sodium, potassium, rubidium. Without any doubt, guys, increasing metallic radius is correct one. Because as you move down the group, there is an addition of each cell. One by one. As you move down the group, okay, what happens? There is an additional cell keep getting added to every atom, which results in increase in size of the atom. Done. Now we have this, guys, increasing ionic size. All these are, guys, isoelectronic species. And remember, guys, for isoelectronic species, size is always compared with respect to, remember, the size of ion is directly proportional to the charge on an ion. More the charge on an ion, more will be the size of ion, and less the charge on cation. So guys, it is inversely proportional to charge on cation. More the charge on cation, more will be Z effective, more tightly it will, more closely it will, you can say, attract the outermost shell. Therefore, out of all these isoelectronic species, aluminium 3 plus will be the smallest one and F minus will be the biggest one. So as the charge goes on increasing, the size will go on decreasing. Done. Clear, guys? So here Al3 plus will be the smallest one, whereas F minus is going to be the biggest one. So the correct order is given over here. Okay, done. Clear? Come on, let us go ahead to the next question then. So here we have the question, the same type of question, isn't it? The species argon K plus Ca2 plus contain the same number of electron. That is true. They all are isoelectronic, contain 18 electron. In which order do their radii increase? Guys, noble gases are having highest size. Noble gases. Why? Because van der Waal radii is to be seen. Van der Waal radii are the largest one. Done. Now we have to compare the size of K plus and Ca2 plus. Just I told you that size of ion is inversely proportional to charge on cation. So it's, guys, Ca2 plus has more charge on it and therefore its size will be lesser. So the actual order of size is this one. Clear? Clear, guys? So which is the correct option here? Yes, it is C. Done. Clear? Shall we go ahead to the next question then? So guys, we have the next question. Which of the following order is wrong? So NH3, PH3, ASH3. There's no doubt out of them all, NH3 is most basic. Most basic has to be least acidic. Same guys, this is less basic than ammonia, so more acidic than ammonia. Same, arsine is less basic than ammonia and phosphine, so more acidic than ammonia and phosphine. Either this way you can understand it, or there is one more guys, comparing the thermal stability. The one which is going to furnish H more easily will be more acidic. Hydrogen is small, whereas guys nitrogen, phosphorus and arsenic are in this order. So more is the difference in size. More is the difference in size. Less stable the hydride will be. Hydride will be. And less stable the hydride will be means more easily hydrogen can be given out. Done. So this is correct. Now the second one guys. Second one is lithium, beryllium, boron and carbon. The first ionization enthalpy. The order is given as first ionization potential. So this order is not correct. Why? Because guys, no doubt ionization, first ionization potential of beryllium will be more than lithium. But if you compare boron and beryllium, here the electron is to be taken out from 2p1, whereas in case of beryllium guys, the electron is to be taken out from 2s2. It is fulfilled, and one more thing, it is more closer to the nucleus, more penetrated to the nucleus. Therefore, more energy is required to take out the electron from beryllium than comparison to boron. So this is the order. This is the actual order, guys. Hope there is no problem. This is the actual order. So ionization energy across the period decreases. Clear? Ionization energy across the period. Yes, what happens to ionization energy across the period? It increases. Okay, therefore guys, carbon is going to have more ionization energy, but if you compare beryllium and boron, the reverse is the order, because in case of beryllium, the electron is to be taken out from 2s2, which is fulfilled and more penetrated towards the nucleus. Therefore, more energy has to be given to it. Done. Now the third one guys, aluminium oxide is amphoteric. Okay. Now, if you compare magnesium oxide, sodium oxide and potassium oxide, the one which is more electropositive, that means the one which is having least ionization energy will be most basic. Therefore, guys, this order is correct, because if you compare the ionization energy, it is maximum for magnesium, followed by sodium, followed by potassium. So potassium out of them all is most electropositive, so its oxide has to be most basic. Done. Now guys, as we move down the group, there is an addition of each shell, and therefore the size increases whether you talk about the metallic radii or the ionic one. Clear? Therefore it is B which is wrong, whereas all the three for A, C and D are correct. Come on, let us go ahead to the next question then. So guys, we have the next question before us is, an atom has electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d3, 4s2. You will place it. Guys, no doubt this has partially filled d orbital. Done. Partially filled d orbital. That means, guys, this is a d block element. And as it is a d block element, remember the group number. How to identify the group number of d block element? Simply the sum of 3d electron here and 4s electrons. And 3d electron is 3, 4s electron is 2. So the group number is 5. Group number is 5. What you need to do is n minus 1d electron and ns electron. Simply add them. Simply add them, we will get the group number, and this is done for d block elements, remember. Therefore, guys, this will belong to fifth group. Is that clear? It will belong to fifth group. Come on, let us go ahead for the next question then. So we have the next question. The first ionization potential of beryllium and boron respectively are. Come on, guys, we need not to calculate this value. Okay, remember. So how it can be done? Just now I told you guys, we have already discussed that if you take out the first electron from beryllium, then we need to take this out from 2s2, which is fulfilled and more penetrated, more closer to the nucleus. Whereas in case of boron, the electron has to be taken out from 2p1, which is partially filled, and in comparison to 2s orbital, it is far from the nucleus or less penetrated towards the nucleus. So less energy is required to take out electron or to ionize the boron atom in comparison to beryllium. So it is very clearly said that first ionization enthalpy of beryllium is more than boron. Done. So let us look for the option in which first ionization enthalpy is more. Here it is first is less, second one is more, so it cannot be. Here both of them are equal, so this also cannot be. Here first is both of them are equal but lesser, therefore it cannot be. So this is the correct one. Guys, this is more than this one. This must be for beryllium, this must be for boron. Clear? Come on. Let us go ahead for the next question then. So we have the next question before us. In crystals of which of the following ionic compounds would you expect maximum distance between center of cation and anion? How to do this, guys? Remember, guys, lithium is small, fluorine is small. This has to be very, very small. Okay. And this again, guys, lithium and iodine, no doubt lithium is small, iodine is bigger. This will be smaller than what? Then, guys, cesium. And the cesium iodide, guys, this is bigger cation, bigger anion. No doubt here the maximum distance is expected. Maximum distance is expected. Clear? Because on moving down from top to bottom, guys, size increases. Both of them lies, guys, yes, both of them lies down the group. Both of them are bigger. So both of them are bigger, they will be bonded at a maximum distance as well. Therefore here the center of cation and anion will be present in this case at maximum distance. Clear? Come on, let us go ahead for the next question then. So we have the next question. Which one of the following ion will be smallest in size? Come on, guys. This has to be O2 minus this way. Okay. So it is very clear from here that all of them are isoelectronic. This was asked, such type of questions have been asked many times, guys. Isoelectronic species. Clear? Now, just now we have seen that isoelectronic species, guys, the size of isoelectronic species is directly proportional to charge on anion, inversely proportional to charge on cation. So all of them, guys, the charge on maximum is, magnesium is maximum. Therefore, this should be smallest. This one should be smallest. So charge on cation is maximum in case of magnesium. So this one will be smallest, whereas O2 minus oxide will be the biggest one here. Done? Clear? Come on, let's go ahead to the next question then. So we have the next question. The element with atomic number 118 will be. Just now I told you, I have given you a trick. So how to predict? How to predict the group number of element with atomic number 100 or more. It is very simple, guys. Group number with atomic number 100, 101, 102, 103 will be 3, isn't it? Now, what about 104? Guys, right from 104 to 118, group number is equal to atomic number minus 100. So it is very clear from here that the element with atomic number 118 will be present in 18th group, and 18th group constitutes all noble gases. So the correct answer over here is B, noble gases. Done. Hope you will not forget this. Come on, let us go to the next question then. So guys, we have the next question. The electronic configuration of an element is 1s2, 2s2, 2p6, 3s2, 3p3. What is the atomic number of element which is present just below the above element in the periodic table? Very simple question, guys. So element, guys, what is the similarity? What is the similarity of elements present in a group? They have same electronic configuration, remember. They have same electronic configuration. Therefore, guys, the element which will lie just below the given element will have the configuration, I mean outermost shell configuration. Instead of 3s2, it will be 4s2. Instead of 3p3, it will be 4p3. It will be 4p3. Done. And guys, all the rest of the shells are filled, only the outermost one are not filled. So how to find out the group number or the block number or the period number? Guys, group number will be, no doubt this is a p block element because p orbitals are not filled completely. Secondly, the group number of p block element are equal to 10 plus ns electron and np electron. Remember. So it will be 10 plus, guys. It will be 10 plus. So 10 plus 2 plus 3 will be 15. So it belongs to 15th group, p block element, period number 4. Highest principal quantum number is 4. So period number 4. Done. So period number will be 4. Now what you have to do is you have to guess the atomic number of the element. Now simply, guys, this is the outermost electronic configuration. Okay, it is the outermost electronic configuration. Done. Done, guys. Simply either you complete the electronic configuration over here, that simply write it 1s2, 2s2, 2p6, 3s2, 3p6, okay, 4s2, 3d10. Done. And 4p3. Clear? Or you can do one more thing. Sorry. Guys, the atomic number is 15. The given element has atomic number 15. Okay. And this belongs to third period. So guys, if you move down from third period to fourth period, simply add 18 to the atomic number of this element. You will get the atomic number of the element lying just below it. So it will be 15 plus 18. That is how much? That is 33. All clear? Or simply add this all. 6 plus 4, 10 plus 6 plus 2, 10 plus 8, 18, then 28, 30, 33. Either you add this all electron or you do this way. you're going to get the answer. So here, guys, this is the correct answer. Clear? Come on, let us go ahead to the next question. So we have the next question before us. Among the following, the one which is most basic is, guys, no doubt Al2O3 is amphoteric. Nitrogen and oxygen, guys, must be acidic. Now, guys, these two are left which can be basic, but guys, out of them all, which is most basic? The one which has more electropositive element. Now, guys, magnesium is more electropositive. Remember, magnesium is more electropositive than zinc. Therefore, guys, zinc oxide is less basic than magnesium oxide. And one more thing, guys, S block elements are more electropositive than D block element. Clear? S block elements are more electropositive than D block elements. Remember. Okay, come on. Let us go ahead to the next question then. So we have the next question before us is Na plus, Mg2 plus, Aluminium 3 plus, Sr4 plus are all isoelectronic. So the order of their ionic size, guys, we have just compared the size of isoelectronic species. How to compare, guys? Simply the size of isoelectronic species is going to be directly proportional to charge on anion, inversely proportional to charge on cation. Done. Now, out of Na plus, Mg2 plus, Al3 plus, Si4 plus, maximum charge is of silicon. Therefore, this will be the smallest one, followed by Al3 plus, followed by Mg2 plus, followed by Na plus. So this will be the decreasing order of their size. Done. So which is a correct match here? Na plus will be biggest than Mg2 plus, biggest than Al3 plus, biggest than Si. So this is a correct match here, isn't it? And why this is so, guys? Why this order is like that? Because, guys, charge on cation means what? Size is actually, guys, size is inversely proportional to Z effective. And on cation, the Z effective is maximum, therefore size is minimum. Will it be? Yes, yes. And Z effective is minimum, then size has to be maximum. Done. So the one which is having highest positive charge will have highest Z effective, means least size. Clear? Come on. Let us go ahead to the next question then. So we have the next question before us. One would expect proton to have very large. Remember, guys, proton have a fixed charge. Okay. So we cannot compare this with respect to charge. Now, ionization potential, guys, they are very small in size. So ionization potential and size are inversely proportional. Remember, ionization potential and size are somewhat this way related. Done. Now, guys, radius, they are very large. Proton to have very large. No doubt, proton, very small particle. So, radius is also very less. Is very less. So, what is left? Yes, hydration energy. What is left, guys? Hydration energy. And remember, this will be maximum for proton because Hydrogen, guys, what is a proton? Let me tell you. If you talk about hydrogen atom, they have one proton and one electron. There is no nucleus. So one proton inside the nucleus and one electron outside the nucleus. So this is hydrogen atom. Once they lose this electron, they are left with the nucleus which is having only a proton. Therefore, they are called so. Done. Why do we call them as proton? It is all because of this reason. Done. So guys, hydrogen have one proton, okay, left with, then it will be called as proton. Done. There is no electron means it is simply the proton, not even the nucleus. Hydrogen nucleus will be simply called as proton because of presence of only and only one proton in it. So can we say that the H plus so formed is extremely small in size, guys? H plus ion so formed is extremely small in size, and the one which is extremely small in size have the biggest size of its hydrated ion, or simply hydration energy is inversely proportional. So smaller the size of cation, maximum the hydration energy. So this proton will have very large hydration energy. Remember, it will have very large hydration energy. Done. Come on, let us have a look at the next question. So we have the next question before us is, which of the following set has strongest tendency to form anion? Now remember guys, the one which are electropositive element, they have a very, like, they can lose electron very easily, and have a strong tendency to form cation. Whereas electronegative element gain electron or share electron easily, or you can say strong tendency to gain electron or strong tendency to form an ion, isn't it? Now guys, gallium, indium and thallium, guys, these are 13th group elements. Okay, and as we move down the group, okay guys, what happens to the metallic property? It increases, or you can say the tendency to form cation increases. Therefore this cannot be the option. Now guys, sodium, magnesium and aluminium, they all are electropositive element. They lose electron easily and form the respective cations, like sodium forms Na plus, magnesium forms Mg2 plus, aluminium forms aluminium 3 plus. Same with vanadium, chromium and manganese. Vanadium, chromium and manganese, guys. All these are 3D series elements which have a strong tendency to form the respective cations. In fact, oxidation state cations are formed out of them, isn't it? So the left option is here, NOF. What's that? Nitrogen, oxygen and fluorine. Nitrogen takes up 3 electron and form 3 minus ion, nitride ion. Oxygen takes up 2 electron and form O2 minus. F takes up 1 electron and form F minus, that is fluoride ion. So guys, all of them are electronegative element. Therefore, all of them have a strong tendency to form what? Anion. Remember. So guys, this is the correct option over here. Clear? Let us go ahead now. Sorry. So guys, here we have the next question. the ionization of hydrogen atom would give rise to. Now, guys, ionization of hydrogen atom. Okay, remember hydrogen atom has one proton inside the nucleus and one electron in the first shell. Done. When it ionizes, it loses one electron and left with its nucleus only, which is having one proton. Therefore, this would give rise to proton. And on accepting one electron, it acquires two electron in its first shell, which is called as H minus, and this is represented as H plus. So the ionization of hydrogen atom would actually give H plus or proton, which is also called as proton. Remember, this is also called as proton. Clear, guys? Come on. Let us go ahead. Hydronium ion, guys. This hydronium ion, this proton, when this proton forms in water, then this hydronium ion, yes, get attached to water molecule due to the lone pair present over it, and it forms hydronium ion. Okay, and hydroxyl ion is this, guys. Okay, it has nothing to do with the proton. It is OH with a negative charge. Done. Come on, go. Let us go ahead now to the next question. So, guys, we have the next question before us is in the periodic table with the increase in atomic number, the metallic character of an element. In the periodic table, the increase in atomic number. Come on, guys, when you move across a period, then also atomic number increases. But during across a period, guys, what happens to metallic character of an element? Guys, here we find most electronegative element, that is first group, which decreases till 17th or 18th group. So metallic character across the period, guys, decreases. So it decrease in a period. What? Metallic character. Done. Now down the group, what happens? Down the group, ionization energy decreases because ionization energy is inversely proportional to size. Due to addition of each shell down the group, size increases, ionization energy decreases, or you can say electropositivity increases. Guys, electropositivity increases, so it should be related this way. Let me write this again. More the ionization energy, less will be the electropositivity. Or you can say electropositivity and size are directly proportional. Bigger the size, more is the electropositivity. So when we move down the group, guys, and electropositivity is directly proportional to metallic property. Okay, metallic character. So it is very clear from here, when you move down the group, electropositivity increases. Therefore, metallic character down the group will also increases. So the correct option over here is metallic character decreases in a period and increases in a group. Done? Clear, guys? Come on. Let us go ahead to the next question then. So guys, we have the next question. The electronic configuration of four elements are given below. Which element does not belong to same family as other? Remember guys, the similarity with respect to electronic configuration as we move down a group or in a same group, guys. In a same group, electronic configuration is same. Electronic configuration remain same. Now let us check which of them have same electronic configuration. Now we have Xc, that is a noble gas with 4F14, 5D10, 6S2. Then 4D10, 5S2. Then 3S2, 3P5, 3D10, 4S2. So guys, all of them like 5D10, 6S2, 4D10, 5S2, 3D10, 4S2. Can you see a similarity over here? But this one, guys, this one is not similar. Why? Because it has 3S2, 3P5. Done. But if you compare this A, B, and C, they resemble to the electronic configuration of the element belonging to which group? Yes, 12th group. How come? They resemble the electronic configuration with that of the element present in 12th group, guys. So this is A is the electronic configuration. There's 4F14, 5D10, 6S2. This must be of Hg, that is mercury. Mercury, guys. Done. Then we have Kr4D10, 5S2. This must be of cadmium. Then we have argon 3D10, 4S2. This is of zinc, isn't it? So zinc, cadmium, and mercury, guys, all are what? All are extremely volatile metal belonging to group 12. Group 12. They are called as non-typical transition metal. They're also called as extremely volatile metal. Done. Done, guys. So, which element does not belong to the same family? All these three belong to the same family. Whereas C does not belong to the same family, guys. Clear? This is neon 3s2 3p5. This is phosphorus. What is it? It is phosphorus, guys. Belongs to 15th group. Whereas this all belongs to 12th group. Done? Come on, let us go ahead to the next question then. So guys, we have the next question. Pauling's electronegativity value for element are useful in predicting. Come on, Pauling electronegativity value are useful in, guys, they're useful in determination of, remember, useful in determination of. Come on, guys, all those who are watching, do like the video, do share the video, and do subscribe the channel if you haven't done so. Do press the bell icon if you have not done so. Do share to all your friends who are preparing for Neet 2021 2022 kvpy or board examination. Come on. And all those who have not taken the subscription so far, do take the subscription so that you can start your preparation in order to ensure your selection. Come on, have a look at the screen, guys. So it is useful in determination of polarity of the bond in molecules. Okay, guys. Now if difference in electronegativity is zero, if delta En be the difference in electronegativity, and let this difference be zero, the molecule will be said as non-polar. And if, guys, the difference in electronegativity is between or greater than 0, smaller than 1.2, it will be, yes, it will be non-polar covalent one. Done. And if it is more than 1.2, it will be polar one. It will be polar covalent one. So here what is done, guys? Remember, guys, just by knowing the difference in electronegativity, yes, we can find out the bond polarity as per is Xa minus Xb, where this are what? Xa and Xb are the electronegativity of atom A and B or elements A and B. Remember. This is actually equal to 0.028 square root of delta E. So guys, if XA and XB are known, delta E can be calculated. Now what is delta E? Delta E is actually actual bond energy minus bond energy of A2 multiplied by bond energy of B2. And here actual bond energy of AB. Done. So this is delta E. Come on guys. If we know this bond energies, we can calculate delta E. Or if we know the difference in electron negativity, we can calculate delta E. Come on. So it is very clear from here that this Pauling's electron negativity value for elements are useful in predicting the polarity of the molecules, isn't it? This was asked in CBSE AI PMT 1989, guys. Remember, guys, the best way to practice, or the best way to prepare for NEET is first of all clear your theory. And that can be done by watching the video. Suppose if you all want to prepare periodic table, say, let us example periodic table. The very first step, what you need to do is just watch a video on periodic table, and so many videos are available of from Unacademy either at YouTube or special classes, or you can take plus as well. Then watch those videos, and after that you need to try to, read the NCRT, then try to solve the exemplars, try to solve this in-text question, try to solve the complete NCRT exercise. After that you must solve these previous year's question paper without any help. Then you must discuss them also. Then NTA mock test is to be solved. Trust me, you're going to rock. You will rock, guys. You will get a lot of confidence if you crack this, if you solve these questions correctly. But remember, you should solve all these questions with a time constraint. The same way as you are sitting in an examination hall, the 45 questions are supposed to be done in 1 hour. Simply take that much time only, or if possible, even take lesser time. Then only you will get a clear-cut idea about your actual performance, which you can. Possibilities are there, of course. But yes, you can get an idea. Yes, if you this paper would have been asked in the NEET examination, how you would have performed. Are you getting my point? So just do this way, guys, because simply clearing theory won't help you. Simply solving paper won't help you. This should be done in a proper sequence. First, clear your theory, solve NCRT, in text, exemplars, exercise. Then solve these full length test papers or mock test papers of NTA, previous year's questions. That too in a time constraint, remember. Otherwise, it won't be help you. It won't be helpful to you. Because in examination hall also you are supposed to solve the questions in a particular time period. How can you expect that all of a sudden or at the time of examinations you are going to rock, though you are not at all practiced for that? So guys, it is very, very important to practice it as well. Okay, come on. Thanks a lot for watching, guys. If you have not liked the video so far, do like the video. Do share the video to all your friends who are preparing for NEET 2021 2022 KVPY board examination. Thanks a lot for watching. If you have not subscribed the channel, do subscribe the channel. Do press the bell icon. Come on, do take the subscription applying this referral code of mine. Thanks a lot for watching. Bye-bye. For now, guys, all the very best. Keep rocking. Keep rocking, guys.